Now let's look at steering robots. The standard steering wheel is replaced with a motor. The motor includes a normal steering wheel, so the driver can still drive the car to the test site. With the RT connected, the steering robot is able to follow the same path on the road consistently. Tests like lane change, rollover, step steer, or even repeatedly a user driving the same route over and over again. The RT is needed in this application because of its low latency and high uprate. To drive within 10 centimeters repeatedly, a higher bandwidth than human drivers is required. This is why we cannot consistently drive this accurately. Also, GPS alone cannot be used because if it was to drop out, the vehicle could not steer. Using an inertial system, the dropouts and the GPS do not matter as much. The robot can hand over the operation if the inertial solution becomes too inaccurate. Let's continue looking at the steering robot. The steering robot is defined by a path that is coordinated into a software or by driving once. Cones can be placed by driving vehicle slowly along a. The steering robot can consistently drive the same path at speed. The steering robot software includes a design suite that allows the user to define paths, or the robot can learn a path driven by the user and repeat it. Cones can be placed on the path by the driver slowly and dropping the cones behind the vehicle. Let's look in more detail about the steering robot. Here are 9 runs driven by a driver. This is shown on the left hand side, and 9 runs driven by the steering robot here on the right. The position of the road is much more consistent with the steering robot, as you can see on the right hand graph. More importantly, the angle that the driver had to turn the steering wheel is much more repeatable with the steering robot. The steering robot represents time and resource saving capability and more reliable outputs from a test. As you can see here on the graphs, the roll angle is at the top and the slip angle is at the bottom. These are also much more consistent using the steering robot. Car manufacturers are starting to pay a lot of attention to the way that the cars handle. Having the tools to measure differences is important. The robot is able to objectively detect very small changes in the vehicle setup.